In this video, we're going to figure out how to make a better foot rig. We already made a really simple foot rig for Mr. Squeegee Feet, but we can improve it and make things better for the animator. There are basically two things to consider here. The first is that, unlike on Mr. Squeegee Feet, our leg rig is going to have IK-FK switching, with separate controls for IK and FK. Therefore, our foot rig also needs to have separate IK and FK controls. The second thing to consider is that for the IK foot rig, we would like to have some kind of foot roll control. A foot roll control is a control on the foot that allows you to do this. The foot pivots back on the heel in one direction, and pivots forward on the ball of the foot in the other. This kind of rig makes animating walks and runs a lot easier for animators because this rocking motion of the foot is so common in those animations. Let's start by considering how IK-FK switching is going to affect our foot rig. We're going to be building the leg rigs exactly the same as the arm rigs. We have IK bones, FK bones, and intermediate bones that switch between them. This means we also need to do the same thing for the foot bones. The intermediate chain will be really simple, just one bone for each part, the upper leg, the lower leg, the foot, and the toe. And what we want to do then is make sure to design both the FK and IK rigs so that the intermediate foot and toe bones can copy them. For the FK foot, that's really easy. The FK foot will be nothing more than a simple FK hierarchy, where the toe is the child of the foot, and the foot is the child of the lower leg. And as long as we align the FK bones the same as the intermediate bones, we're good to go. For the IK foot, it's going to be slightly trickier, but still not too big of a deal. The simplest possible design we could make is the same design as Mr. Squeegee Feet's foot rig. It's also just two bones, one for the foot and one for the toe. And the foot bone serves as the leg's IK target as well. This rig is trivial to build and is easy to hook the intermediate bones up to. They just copy the rotation of the foot and toe bones. And in fact, other than adding foot roll, this is really all we need. To add the foot roll, we're going to build the rig around these two bones, so that the rig has to move these bones to move the foot. That way, the constraints for the IK-FK switching can still just copy these bones. The heart of the foot roll rig is what I like to call a rocking rig. Not because it rocks hard at a concert, but because it rocks back and forth. The goal is to create a control that will cause this bone to pivot back on one of its endpoints, and pivot forward on the other. There are multiple ways to accomplish this, but probably the easiest to set up involves giving this bone a parent. Have you noticed by now that parent-child relationships are really powerful and useful? This bone that we already have can already pivot back from its head, so that's taken care of. We just need to make it able to pivot forward on its tail. To do that, we can simply give it a parent that pivots around that point. Now when we want to pivot forward, we can just rotate the parent. So now we can pivot our bone at either of its endpoints by either rotating it directly or rotating its parent. Now all we have to do is create a control that automates switching off between them. Let's create a new bone to be that control. I'm just going to duplicate the parent for that, and position it a little bit differently. Let's start with the rocking bone itself. What we want to do is make the rocking bone rotate with the control bone, but only when it's rotated in this direction, not this direction. The first step of this is easy. We add a copy rotation constraint. You'll notice, of course, that it's copying the world space rotation of the control bone. Switch the constraint to use local space. Now when we rotate the control, the rocking bone rotates too. When you're doing this yourself, you may get a strange result with the rocker rotating in a strange direction. If you do, that's because the roll of the bones aren't aligned properly. When the control rotates on its x-axis in the positive direction, the rocker bone will rotate on its x-axis in the positive direction, even if that axis is different from the control bone's. For example, if I change the roll of the rocker bone and rotate the control, the rocker bone now rotates in this other direction. This is both the beauty and curse of local space constraints. To fix this, just adjust the roll of the rocker bone until it works correctly. So now that the copy rotation is working, we need to limit the rotation of the rocker bone. Thankfully, there's a constraint for that, conveniently called limit rotation. Add a limit rotation constraint to the rocker bone. The very first thing we want to do is switch the constraint to use local space. This is very important because otherwise, when we rotate the parent, the rocker bone wouldn't rock forward with it. It would also cause problems in the larger foot rig when the entire foot gets rotated in space, if we use world space. So this constraint allows us to limit the rotation of the bone on any of the three axes. We only want the x-axis, so check that on. By default, both the minimum and maximum limits are set to 0, so our rocker bone won't be able to rotate at all. Since the crossover point where we want it to stop rotating is at 0 degrees, we know one of these numbers needs to be 0. We can use trial and error to figure out which one. Rotate the control in the direction we want to allow, and then play with the min and max values to see which one allows it. Looks like it's max. So set max to something large but less than 180 degrees. I'm using 170 degrees. Now the rocker bone only copies the rotation of the control in one direction. To complete the rocker rig, we just do exactly the same process for the parent bone, except we limit its rotation in the other direction. Ta-da! Now the rocker bone rocks back and forth. Both the rocker and the parent are copying the control's rotation, but thanks to the limit rotation constraints, they trade off who's doing the copying when they cross over 0 degrees, and that causes the rocking motion. If we hide the parent bone, you can more clearly see the effect this has. Anyway, this is the basis for the foot roll rig. So going back to our IK foot rig now, let's see if we can't figure out how to put this rocking thing in there. The first thing we're going to want to do is rename the foot bone to be a mechanism bone. The user won't be directly using this anymore because it's going to be under the control of the foot roll rig. However, it will still be the IK target for the leg, and it will be what the intermediate foot bone copies its rotation from. So with that out of the way, let's get started building the foot roll rig. The first thing to do is identify where the heel of the foot is. We don't have an actual model here, so let's just pretend that the heel is here. The rolling action is going to rock between the heel of the foot and the toe joint of the foot. So to create a rocker bone, let's simply extrude from the base of the toe and put the tip at the heel. Now create the parent of the rocker bone. I'm going to do this by another extrude and then parenting the rocker bone to it. Now let's create the rocker control. And let's set up the constraints. So now the rocking rig is working. We just need to hook the foot and toe bones up to it. The first thing to do is parent the foot bone to the rocker bone. This sort of works, but we don't really want the toe rotating on the forward roll. Fortunately, we can easily fix that by parenting the toe to the rocker parent. Since the parent only rotates on the back roll, parenting the toe to it makes the toe also only rotate on the back roll. The only thing we need to do now is create an overall control to position the entire foot in space. The principle for this is actually a lot like the root bone. We create a new bone and parent everything that doesn't already have a parent to it. In this case, we would like the overall control to, at least by default, have the same position as the foot bone. So let's just duplicate the foot bone and clear parents on the duplicate. Only the rocker parent and rocker control are parentless at the moment. I guess we could call them orphans. Poor orphans. So let's give them a parent. Make them the children of the overall foot control. We also probably want to set the foot roll control to use Euler rotations and lock its axes. And let's also lock the translation axes on the toe. You can also set it to use Euler if you want. YZX is a good rotation order for this, for the same reason as the fingers. And ta-da! We're done. There are only 3 control bones here: the overall control, the foot roll, and the toe. Everything else will be hidden from the user. And that's it.